Hello, in this video we're going to continue with permutation. We're going to see two examples dealing with permutation. So here, for example, compute the value of the following expression. So this is permutation 2 out of 7. So using the formula, we get 7 factorial divided by 7 minus 2 factorial, which is 7 factorial divided by 5 factorial. You could just multiply 1, 2, all the way 5, 6, 7, and then here you have 1, 2, all the way to 5. So if everything cancels out, we end up with 6 times 7, which is 42. And the other example is very similar. So 8 is n and r is 5, so 8 factorial divided by 8 minus 5 factorial. And again, do the calculation and it will be 6,720. Let's see an example here that deals with some scenario. You have 10 athletes compete in an Olympic event. So here is what I'm thinking. Gold, silver, and bronze medals are awarded. So here it tells me that the order matters, so it must be a permutation. We have 10 athletes. So n is 10, and we pick r, the ordering of 3. So how many ways can the award be presented? So this is permutation. You pick 3 out of 10, which is also can be written as 10 3. It's 10 factorial divided by 7 factorial, which is 720. The other example is, how many ways can 6 people be seated on 6 chairs? Again, I'm thinking 6 people, n is 6, sit on 6 chairs, so you pick 6 out of 6. So this is also permutation. That means 6 factorial, 0 factorial, as we said before. This is just 0 factorial. Since 0 factorial is equal to 1, so it's become just 6 factorial, which is 720. How many permutations of the letter A, B, C, D, E, F contains the letter D, E, F together in any order? So here is what we have. We have basically 6 letters, but we want this D, E, F to stay together. So you could permutate the rest, A, B, and C. So for example, we could have A, B, and then have D, E, F together. And then maybe I'll have a C later. So how many different ways we could do this? So we think of it as if we have 4 letters basically, as we see here. So we have 4 factorial ways to arrange these 4 letters. I'm thinking D, E, F as 1 letter. So we have 4 factorial ways to arrange A, B, C, and then D, E, F. Also, we have 3 factorial ways to arrange D, E, F, because D, E, F can be F, E, D, and so on and so forth. And therefore, the total possible way of arranging A, B, C, and then D, E, F together will be 4 factorial times 3 factorial, which is 144 ways. So these kind of examples, it's good to picture it. See what's going on, and then whatever you need to permutate, arrange, you could do that. Here is another example, kind of similar. So we have the professor dilemmas how to arrange 4 books. He has 4 books on operating system, OS, and 7 books in programming, and he has 3 books, data structure, on a shelf, such that books on the same subject must be together. So again, if you think about it, 4 on operating and 7 on programming, the same way, should stay together, and 3 on data structure should stay together. So by picturing it here, what would be the answer? So we have 4 factorial to arrange operating system, 7 factorial to arrange programming, and 3 factorial to arrange data structure. And we are not done, because we could think of each one of the category of the books can be rearranged as well which give us another 3 factorial of arrangement. And again, by multiplication principle, the total way will be 4 factorial times 7 factorial times 3 factorial times another 3 factorial, and that's the answer. This is how many different ways he can rearrange these books. Okay, here we have how many batting orders are possible for 9-man baseball team. So if you have 9 men, how many different orders we have? We have 9 factorial orders. Simple as this. How many permutations of a character computer are there? So how many of the permutations end with the vowel? So here we have 2 questions. So first we have computer. What I do, I look at it, I see, is there any letter that repeats? I don't see any repetition of any letter. So we have 8 factorial ways. So 8 factorial ways we can rearrange computer. The word computer can be R first, and then E, and then T, or so on and so forth. And that's the first question. The second question is said how many of the permutations end with vowels. What vowels we have in here? We could end with the O, or U, or E. If we end with the O, that means we have 7 factorial ways to arrange the rest of the letters, and the same if we end with the U and if we end with the E. So basically we have, for the second question, 3 times 7 factorial ways to arrange the word computer where the vowel stays at the end. This is very simple. Back in how many different ways can 19 people be seated in a row? So you could stop the video and think about it. So very simple, because no restrictions, just in a row like this, we could have 19 factorial different ways. Now it's a little bit different in how many different ways can 11 men, 8 women be seated in a row if the men all sit together and the women all sit together. So you could stop the video and think about it. So having all the men together, we have 11 factorial different ways. And having all the women together, then you have 8 factorial. And then what happened? You could sit them that the women first, then the men, or the men, then the women. So we have 2 factorial there. So the answer, we have 2 factorial times 11 factorial times 8 factorial. And again, 2 factorial, because we could say men first, then woman, or woman first, then man. Another one here, it's similar, but we're sitting in a circular table, not in a row. How many different ways can 11 men, 8 women be seated around a circular table? Only relative position in the circle can be distinguished. You could think about it as only 3 people sit on a table. I'm here, I'm number A, and then there is 2 people, B and C. So I'm fixed in that chair because only relative to me, who is my left, who is my right, that's what I think about on this table. So I could be sitting here and C can be on my left, then be on my right, or C on my left and then B on my right. So there is only 2 ways, even though there are 3 people. So you could the same way think about it as 11 men, 8 women. They don't have to be together, but how many total is 19? How many different people these 19 people can sit together? So as I said, sit 1 person on a chair, anywhere in the circle. The position doesn't matter. And then what's left is 18 people to sit. So there are 18 factorial different ways these 19 people can be seated on a circular table. You fixed one and you permutate the rest relative to that one. That's why it says only relative position in the circle can be distinguished. I hope these examples were helpful.